Welcome to the Deep Dive. Today we're looking at a classic tech problem.
Mhm.
How do you get an old analog VGA signal to a new digital DVI screen?
And not just to a screen next to it.
Exactly. To a screen that's, well, incredibly far away.
Yeah.
Our source material is the product page, the NTI VGA-DVI-FOSC converter extender.
It's a very specialized piece of kit.
It really is. So
Yeah.
let's unpack this thing and figure out what it does and, more importantly, why it exists.
Right.
Okay, so at its heart, the main job is that conversion, taking that old school analog VGA signal.
And turning it into a crisp digital DVI signal that a modern display can actually understand.
But the documentation makes it really clear. This isn't just, a simple adapter you buy for $10.
No, not at all. You have to think of it as a complete system. There are two main parts. You've got the transmitter unit.
The VGA-DVI-FOSC.
That's the one. And then you have a specific optical receiver on the other end. They have to work together.
And the transmitter itself has a neat feature, something about a local display.
Yeah, it's actually really important for pros. It takes the VGA input, but it also provides a local VGA output right there on the box.
So you can see what you're sending.
Exactly. You can have a little monitor right at the rack while the main display is, well, a very long way away.
Okay, and that brings us to the really wild part, the distance. I mean, the spec sheet says up to 1,640 feet.
500 meters.
500 meters. How does it even do that? That's not a normal cable run.
Well, that's the fiber optic magic, isn't it? It converts the signal into pulses of light and sends it down a single strand of multi-mode fiber optic cable.
A glass cable, essentially.
Essentially, yeah. And once your signal is light, it gains a huge physical advantage.
And that advantage is?
Immunity. Total immunity to RF interference. The spec sheet calls it out specifically.
Right, so if you were trying to do this with a copper cable.
Oh, it would be a disaster. Over that distance, a copper cable is basically a giant antenna. It would pick up noise from power lines, from motors, from anything. Your video would be a mess.
But light.
Light just doesn't care. It's a perfectly clean channel from point A to point B.
So you get the distance, you get the clean signal. But what about the resolution? Does all this conversion and extension degrade the image?
You'd think so, but no. The system is rated for resolutions up to 1920 by 1200.
Which is WUXGA, a bit more than standard 1080p HD.
Right. It gives you that extra vertical space for, toolbars or data readouts in a control room. It maintains very high fidelity.
That focus on professional environment seems to be all over the specs. It's a small box, just a few inches wide, but it's also got these regulatory approvals, ICCE, FCC, OROHS, but also TAA compliant. What does that signal to a buyer?
TAA is a big one. It means it's approved for use in, say, government or military contracts. It has to do with where it's manufactured.
So this is serious hardware.
Absolutely. You pair that with the wide operating temperature from freezing up to 122 Fahrenheit, and you know this is built for an industrial rack, not a desk.
Which I guess brings us to the price. It's over $1,000.
Yeah. And that tells you that solving this specific problem-pristine analog to digital video over 500 meters is either very difficult or the places that need it consider it absolutely mission critical, or both.
So when you put it all together, what this really shows us is that specialized hardware is still totally necessary when you're pushing the physical limits of distance and trying to bridge these different video standards.
It's a very elegant solution to a really tough industrial scale problem.
For sure.
And it leaves you with a final thought, doesn't it? Given that major institutions are still spending four figures to keep their legacy VGA sources running,
Yeah.
what does that really say about the so-called end of life for these old standards? It seems to me that VGA is probably going to be with us, buried deep in critical infrastructure for a very, very long time.